Hey friends, welcome back. Today we're heading straight into the heart of our galaxy, the Milky Way. You'd think since we live here, we'd have it all figured out by now. But the truth is, the center of the Milky Way is still one of the biggest cosmic mysteries we've ever faced. And for decades, scientists thought it was simple, a giant black hole, case closed. But the closer we look, the more interesting and sometimes stranger the story becomes. So let's break it down. What's really going on at the center of the Milky Way? And if it weren't a black hole, what else could it possibly be? For nearly 50 years, astronomers have believed there's a supermassive black hole right in the middle of our galaxy. They even gave it a name, Sagittarius A star. It's about 26,000 light-years away, hiding behind thick clouds of dust and gas, and it weighs around 4 million times more than our sun. That's mind-bending. Black holes don't glow. By definition, they trap light. But we can detect Sagittarius A star indirectly. Stars whip around it at incredible speeds, far too fast for any ordinary object to explain. One famous star, S2, completes an entire orbit in just about 16 years, an astonishingly tight, fast loop for something so massive. Packing millions of solar masses into such a tiny volume? That screams black hole. And in 2022, the Event Horizon Telescope gave us a history-making first image of Sagittarius A star, the telltale bright ring of superheated gas surrounding a dark central shadow. It's some of the strongest evidence that we're looking at a genuine supermassive black hole, not just something heavy. So, case closed? Mostly. But there are twists worth exploring. For years, Sagittarius A star was considered a quiet black hole compared with the raging powerhouses in other galaxies. It feeds, just not ravenously. Then around 2014 to 2015, astronomers saw an uptick in X-ray flares, like the galactic center had started chattering. One likely trigger was a close pass by a mysterious object called G2. At first, G2 looked like a simple gas cloud headed for a shredding. Later observations pointed to something more interesting, a star that had likely merged from a binary pair, wrapped in a dusty cocoon. As it grazed near Sagittarius A star, some material probably peeled off and fed the black hole, lighting up those flares. And here's the punch. This isn't some sci-fi event in a distant galaxy. This happened just 26,000 light-years away, practically in our galactic neighborhood. The flare burst wasn't a permanent change. It was a specific episode that taught us how this black hole snacks when fresh fuel shows up. About 40 years ago, astronomers discovered long, thread-like radio structures dangling near the galactic center. Back then, there were only dozens. With modern radio imaging, we now see at least 1,000. Some are up to 150 light-years long. Cosmic harp strings glowing with synchrotron radiation from electrons spiraling near light speed in magnetic fields. And here's where you can almost feel the hair stand up. These aren't computer graphics or a sci-fi sketch. They're real threads of energy stretching across space in our very own galaxy. What's driving and aligning them? That's still an open question. The population seems to include different families, some long, vertical filaments, and also shorter horizontal ones. There are hints that certain subsets may be linked to past outflows or winds from activity near Sagittarius A star, but the full picture is still forming. It's one of the most visually striking and undertold mysteries in our galactic backyard. Every solid mystery attracts bold alternatives. A few researchers have explored whether some observations near the galactic center could be modeled by a dense clump, or cusp, of dark matter, rather than a single point-like black hole. Dark matter is the invisible mass that seems to make up most of the matter in the universe. We infer it from its gravitational pull. Here's the key, though. Today's evidence overwhelmingly supports the black hole interpretation. We have decades of precision measurements of stellar orbits behaving exactly as predicted in a strong gravitational field. We've detected relativistic effects near pericenter, and we now have the direct ring image consistent with a black hole's shadow. The dark matter core fits are interesting thought experiments, but they remain highly speculative compared with the black hole model that explains multiple independent lines of evidence at once. Also important, when people talk about mysterious gamma-ray excesses toward the galactic center, they're often referring to a separate phenomenon in high-energy astrophysics, likely not a signature of Sagittarius A star itself. It's easy to conflate these topics. In reality, several distinct processes can light up the same region of sky. Why should anyone care what sits in the Milky Way's core? Because the center acts like an engine room for the entire galaxy. It shapes how gas flows, where stars form, and how galaxies grow and age. And here's the wild part. This isn't abstract textbook science. We're talking about a real cosmic laboratory, close enough that we can watch Einstein's predictions play out down to tiny orbital shifts and redshifts on human timescales. Our galactic center is the perfect place to test gravity, magnetism, and high-energy physics under extreme conditions. So what's at the center of the Milky Way? The overwhelming evidence points to Sagittarius A star, a supermassive black hole about 4 million times the mass of our Sun. Around it, a dense, complex nuclear star cluster, threaded with mysterious magnetic filaments and bathed in multi-wavelength activity that flares when fresh fuel arrives. Alternative ideas, like concentrated dark matter, exist on paper, but they don't match the breadth and strength of current observations the way the black hole model does. Whatever is happening there, it's powerful enough to anchor the orbits of hundreds of billions of stars, including our own Sun. It's compelling enough to earn a Nobel and the first ever image of our galaxy's central black hole. And it's dynamic enough to keep surprising us with filaments, flares, and clues to episodes of past activity. The center of the Milky Way is a reminder that the universe still has secrets. Huge, glowing, gravity-bending secrets sitting right in our galactic neighborhood. We've mapped continents and oceans, walked on the moon, and photographed a black hole's shadow. But the heart of our own galaxy still invites questions that could change physics textbooks. So what do you think? Is the case for a black hole already closed? Or do the filaments and flare episodes hint at deeper layers we haven't uncovered yet? Drop a comment with your take, and subscribe because the next observation campaign might rewrite the next chapter.